Hello everyone. In this video, we will learn how we can apply Solidworks into a mechanism lesson. We can make position analysis or velocity and acceleration analysis in Solidworks. In order to make that, I will use an example, which is a numerical example. I chose that because after we did our uh, analysis in SolidWorks, we can compare it with this numerical example. So let's start. When we open the SolidWorks, this scene will appear on us first. Then we need to make a new part first, and then we will use assembly. But first, we will choose part section. After we choose it, this scene will appear on us. There are features, sketch. These are not important for now, so I will close them. This sketch section is for 2D drawing, and this features section will be for 3D. Okay, and here there is history chart here. All of our operations will be listed in here, and also there are three main planes here: front, top, and right side wheels are here. Actually, these parts are in English, but these three are in Turkish. I don't understand that. Not important. So first we will start with drawing these four members. This is the four-bar mechanism, so we will have four bars. First, let's draw this part with 30 millimeter. In order to start to the drawing, we need to choose one of these planes first. So I will choose front view, right click and choose the sketch button. Then it will be active and there will be a sketch here. If the origin is here and active, then we can start to do sketch. There are buttons here. This is for drawing lines. This is for drawing circles. This is for rectangles or something. This is for arc, ellipse, spline, polygon, or slot. Uh, I will use this rectangle. I will start with this one. When I choose it, it will ask to select a point. I will choose the origin and I can make any length. I will choose some of these points also. And this is an rectangle. But what was the length of this one? It was 30 millimeters. So after I choose it, after I draw this rectangle without any dimension, then I will start to dimension it. So select Smart Dimension here and select this line. It will be 30 millimeters. So if I write here 30 millimeters, it will be directly 30 millimeters. So it is different from AutoCAD, because in AutoCAD, when we draw, we need to make it with its dimension. But here we draw first, then we dimension it. So the width is, let's say, 5 millimeter. It is not important for our example. So let's say it's 5 millimeter. Okay. Then let's make circles here and here for the connections with the other bars. So we put the circles here and here, and we will dimension it now. Let's say this is 2 millimeters from this line, and to be in the middle it should be 2.50 millimeters. And let's make the diameter 2 millimeters also. So make this also 2.5, and the diameter is 2 millimeters. So click Escape to exit the dimensioning. Actually, if we connect the bars from these circles, the 30 millimeter is wrong, because it should be 30 from this circle to this circle. So click this 30 millimeter, select this one, and click delete on the keyboard. Then click the centers of the first, select dimensioning, click the centers of the circles, and click any point here. This should be 30 millimeters. Now it's okay. So I draw this rectangle, so I can exit from the sketch. If I click this one, I will exit the sketch, and it will be saved. But if I click this one, the sketch will not be saved. So we will click this one. So there is an object with two dimensions. So come to features section. There are options here. I will make an extruded section. So select this sketch and click the extruded boss base. It will make a 3D object with giving this object a width, a thickness. So what is thickness? It can be anything, but I will give 2 millimeter. So I think this is okay for a bar. There are options here also, but for now this is blind. Blind means whatever you give to here, it will, the thickness will be this millimeter. So click this one, and we have 3D object like this. But I think we have a wrong part, so we cannot see the circles. So I will delete this boss one. I said that the operations will be listed here. So this is the sketch we did, and this is the boss operation we did. So if we delete this one, the boss operation will be deleted, but the sketch will be here also. So let's click right and click edit sketch. When we in the sketch, go to the features section, click extruded boss plate again, and if you see it like this, 2 millimeter, click OK, then we will have circles. So this is the first bar in here with 30 millimeter. So I need to save it. So click File, click Save As, and for bar mechanism, and let's say this is the bar one, and save it. Then click Close, and again new part. OK. Again select the front view, select sketch, choose the center, rectangle with center, click the origin, click any point here. What is the length of the other bar? Is 60 millimeter. uh, and then we will dimension it. So click Smart Dimension. This is 60 millimeter. This will be 5, to be same with the others. Then put two circles to here and to here. It is not really important. You can put the circle to here also. Then click Smart Dimension. Say this is the 2 millimeter, and say from here the center of the circle will be 2.5. It will come to here. What was its dimension? I think it was 2 millimeter. So center and this line will be 2.5. This line and this center will be 2, and diameter, to give diameter we will choose the circle 2 millimeter. So come to features, make extruded boss base, here 2 millimeter. Okay, and let's save it. The other bars will be done with same procedure, so I will skip these parts. Okay, I draw all of the parts. Here we can see bar 1, bar 2, bar 3 and bar 4, and I saved all of them to here, any of the folders. Bar 1 with 30 millimeter, bar 2 60, bar 3 50, and bar 4 is D, it is 70 millimeter. So now we need to make an assembly from these separate parts. So click the assembly for this time and click OK. Now Solidworks wants me to take the parts to here. So click browse. If this folder is not open, you need to open it. Then choose these 4 bars with control tool and open them here. So put the bars any of the points. So this is which one? Let's make this is the biggest one, so I think this is bar 4. This is bar 2, bar 3 and bar 1. We can move these bars in SolidWorks, but this one is fixed. The first bar, the first object actually, here we when we take the parts to here, the first object we take will be fixed. So if we want to move it, we need to click right on the object and click float. Okay, then we can move it also. So all of the objects are moving. But this bar 4 with 70 millimeter should not be moved. So I will fix this bar in somewhere. It's not important. So click this bar and click right click and say fix. Then it will be fixed here. Then this is the bar 1 with 30 millimeter. Let's say A. I need to connect this circle and this circle. So if you look from here, there are mates. We need to mate all of the objects with the others. So if you click mate, there are options here. These options, for example, coincident means any two objects will coincident with the other, like this. But we don't want this one. This makes parallel any of the plane to another, like this. This makes perpendicular. This makes the tangent. But we want the circles to be concentric. So click concentric and click the inner circles of this one and for this circle. Click OK and also click OK here. Then this object, these circles will be concentric with the others. But I want it to be coincident. So let's mate them again. Click mate, click coincident. This plane of bar 4 and this plane of bar 1 will be coincident. Click OK. Then this will move only in this angular direction. So I cannot take it away from bar 4, or I cannot move it to the right, move it to the in this direction or in this direction. Okay, it will only move with an angle. Okay, we done it. Then A will connect with the bar 2. So this is the bar 2. Okay, let's continue. This is bar 2 we said. So we will connect it with bar 1. Actually here this moves freely. So we connect the points or the circles or something, and we want it to move according to our claims. So again, let's make them. We can make this connection like this. First, select coincident. I want this plane should on this plane. So they are in the same plane, but I can now again move it up and down or left and right. This is the x direction. You can see here. This is the up and down is y direction, and this is the z direction. So when we coincident with these two planes, I only restrict the motion in z direction. I cannot uh, move it in plus z or minus z, but I can move it in x and y directions. So again, mate and click concentric, click these inner circles, this one and this one. Then the centers of these circles will be in the same direction, in z direction. Then click OK. Then finally, let's connect the last bar. Made it. So this plane and this plane should be coincident. This circle and this inner circle will be concentric. Okay. And also this circle and this circle will be concentric. Click OK. Now if you move these parts, you can really move like this, as you see. Finally, let's save this assembly. Click File, click Save As, click this one. Let's say forward mechanism. and click here. Okay, we draw the forward mechanism, so we can continue with the position analysis. Okay, now we can start the position analysis. But first, I want to show you something. When we make this motion, it seems like there is an interference here. It doesn't affect the motion actually, but for more reality, I want this bar to be here. So let's come to here and delete this one, so I can move this bar now and make another mate coincident. Now for this plane, this plane is coincident. So now there is no interference. Okay, let's go to the numerical example. What it says, calculate the values of theta 4 when the input angle theta 2 is equal to 30 degrees. So we will make this angle 30 degree and we will measure this angle. So let's make another mate here. Click mate, click this angle, it will be 30, where will be 30? Between this and this plane will be 30. Okay. Now the forward mechanism cannot move because it should be 30 degree. So let's check this angle, click evaluate, click measure. This and this one selected. Actually, not this. Okay. Do not click the evaluate. Only click control. Select this plane and this plane. And here the angle is given to you. This angle is this angle. So it is 84.39. What we have found in the numerical example, it's 84 degree. So it is true. This is one option, but this mechanism can be in the opposite side also. Like this one. In order to make this, let's delete this 30 degree mate and make this bar the opposite side. So when we move this bar, arrange this angle to the 30 degree. Click mate, click 30 again. This one and this one should be 30 degree. So which angle we need to measure? This angle. With Control tool, select this plane and this plane, and here the angle is 122 degree, which is equal to numerical analysis. Up to here, the solution was for one specific angle, but we can determine all of the angles also, and also we can determine the trace path of any point. So in order to make that, first we need to open this section with add-ins and click the Solidworks motion. If it is not open, we need to open it first. There should be a click here in the Solidworks motion part. Then click OK. Then in the bottom there are three sections. One is motion study. So if you click it, click create new motion study, and let's start a new motion study. In here we can make any of the mechanism analysis. After we open here, we need to choose here the motion analysis, not animation or basic motion. Then the first thing, we need to give a motion to any of these bars. So I will give a rotary motion to here. I will give a motor to here. So in order to make that, I will choose this motor. I will click it. Then it asks me what I want to give, rotary or linear motor. I will give rotary motor. Here it asks where to put the rotary motor. I will put it to here, this inner circle. Then it asks the constant speed, or I can give distance, oscillating segments, or any other spot. First we will give constant speed, which is revolution per minute. Let's say this is 60 revolution per minute, and then click OK. So now we give a rotary motion to this bar. Then if we click this calculate button, it will calculate the all motion. For 5 seconds. We can change this seconds also, the length of the analysis, but I will left it like this. So it calculated the motion. We can now see the results. Here there is result and plot section. Click this one. The result section will open. We will choose what we want to see in here. I want to see the angle of this bar with the horizontal. So I will choose first displacement velocity acceleration button. Then I will choose angular displacement and directly magnitude is come. Then I will choose the planes. So I will choose these two planes to see the angle between them. And finally it asks according to what you want this angle. You can choose time or you can choose any other result. For example, you can choose any new result, displacement, and if you choose this plane, it will give you the results according to this angle. But first I will choose the time and click OK. So it gives me the angle of this part in the 5-second time. We can see it also like this. If I give the motion again, you will see the red line according to motion, but the motion is not smooth, so I need to make some change. In order to make change, click to the motion study properties button and it asks frames per second. If I make this 200 and click OK and then click again the calculate button, it will be more smooth. Okay, now it's calculated. So again, let's make this graph displacement, angular displacement, magnitude is of this angle we choose according to time. Let's make this. Now if we click motion, okay, let's make this one more slowly. And click motion. So the red line starts from here and goes with this angle. For example, in this view, the red line is here, so the angle is like minus 175 or something. So the angle is like that. Actually, normally it will make a motion like this, but it directly goes up from minus 180 to minus plus 180. It is because it uh, goes from minus degree to the plus degree directly. Basically, this is the angle change of this bar according to time. Now, this is plot 22. Now we can add also this angular displacement of this bar according to time. But I don't want to create a new plot. I want it to add it to the plot 22. Click OK. Then click plot 22, right click, show plot. The red one is for bar 3 and the blue one is for bar 1, the angle change according to time. So basically we can directly find when the blue is any degree, what is the bar 3 degree of the bar 3. We can also export it to a Excel. Let's say bar motion and click save. In here we can see according to any angle and time the other angular displacement. So first let's they are in one the all results in only one column. I will apart them. So in this section I click this one, I click this one, I will apart them with comma, not only this one, for all of them, comma, fine. Now I apart them. This is the time, this is the angle of the first bar, this is the angle of the third bar. So according to any angle, what is the angle of the third bar we can find directly. For example, if the angle of the first bar is 65 degree, the angle of the third bar is 92 degree. So basically we can also apply it to the bar 2 or any other mechanism. Also we can find the path of this point here. Click displacement, velocity, acceleration and click trace path. It wants me to choose a point, so I will choose this point. It directly gives me the head of this point in the analysis period. If you click OK, so the motion will be on this path. Also, we can find head of this point. Click OK, click play. So it will go from here to here only, and this point falls with a circular motion. I hope it's understandable up to here. We will continue with velocity analysis in upcoming videos.